In this video, we're going to go over the basics of scientific notation. It's called scientific notation because in science, we have numbers that are huge, lots of zeros at the end. For example, the mass of the sun has a bunch of zeros after some numbers, right? Because it's huge. In science, we also have very small numbers, like the size of a bacteria, incredibly small number, 0. With lots of zeros before we put other numbers there, okay? So scientific notation is called scientific because in science you have numbers that are very large and very small at times. Now, it isn't practical to write 30 zeros in a textbook about astronomy, right? So there is kind of a shortcut way of representing these huge numbers and these really small numbers, okay? And that's called scientific notation. Now, there are a few rules with scientific notation. The first rule is that, as you can see here, these numbers are all in scientific notation right here. As you can see, the first number has to be between 1.0 and I'm putting x as the number. It has to be between 1.0, it can also include it, and it has to be less than 10, and it's got to be greater than 1.0 and less than 10. So it can't be 10, but it can be 9.999. Got it? So that first number has to be between 1 and 10. Okay? Now, the next thing you do in scientific notation is you put an x here, and that x, usually x means, like, at this point in math, it's usually a variable that we're doing, right? In this case, x is actually standing for multiplication. So it's like the first multiplication symbol you learned. X actually does stand for multiplication in scientific notation. And then you have a 10 raised to a certain power. And that will tell you how many times to move the decimal either to the right or to the left, okay? So let's just write each of these. These are all three of these numbers are in scientific notation, but we're going to write all three of them in standard form, which means with all of their zeros, okay? So 6.3 times 10 to the fifth means I take my decimal point and I move it to the right 5 places. 1, 2, 3, 4, 5. And then there's the decimal's new location. I fill in the spaces with zeros. And so now my number is 6, 3, and then 4 zeros. All right, that's going to be 630,000 meters. All right, that's how long that river is. Interesting. So taking a look now at the size of this bacteria, well, let's go ahead and do the star system. So we have 7.1, and then we are going to move the decimal to the right 17 places. Ouch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. All right. And then I'm going to fill that in with zeros. Wow. That is a huge number. A lot nicer to write it like this than like this. Okay, so that's how scientific notation works when the exponent is positive, positive 5, positive 17. But what if the exponent is negative? Well, if the exponent is negative, you just write your number. In this case, it's 6 or 6.0. And then you actually are going to move the decimal place to the left 7 places. 1, 2, 3, 4, 5, 6, 7. So there's where it is now. And we have 0.000006. So the new number is 0.12345 zeros, then the number 6. Okay. Again, much nicer to write this number in scientific notation than to write it out like that. But they're both the same number. Now, let's take a look at scientific notation by correcting the mistakes in these problems down here. So we've got, all right, that's not wanting to work. So one sec. So we've got some mistakes in some of these. Well, some of them are written correctly. So this one is written correctly, okay? that would just, you just move the decimal over 2 places and it's 0.0451. Totally fine. This one is not correct because this number is not between 1 and 10, right? So what we need to do is rewrite it as 7.89 times 10 to the, well, it can't be 10 to the 5th because when I change that 7, when I change the decimal place there, that changed what the exponent would be, right? So maybe you can see this right away, or maybe you want to write it out and be very clear about it. Let's go ahead and turn this number into standard form, and then we can see what our exponent should be. So 0.789 times 10 to the 5th means move to the right 5 places. 1, 2, 3, 4, 5. Okay, so the new number is going to be 78900. All right, how would I turn that number into scientific notation? Well, I would need to put a decimal here, right? 7.89. And I would need to move the decimal over 1, 2, 3, 4 places. Yeah. So it's going to be 10 to the 4th. 7.89 times 10 to the 4th. That is going to be my corrected version. So, oops, should have left that up there. Okay, moving up to the next problem. We've got a number that is not between 1 and 10. And so what we need to do is put the decimal right here to make it between 1 and 10. Again, if you can see what the new exponent should be, that's great. If you can't, then just write it out in standard notation. So this is going to be 31.5 times 10 to the 2nd. That means the new number is 3150. Okay. And so that's going to be putting a decimal here. That means I'm going to need to move it 1, 2, 3 places. So that is going to be the new exponent there. You can see that it's one more, right, in that case. And then finally on the last one, oh man, this is fortunately written correctly. If it wasn't, we could still figure out though how to get the new exponent, okay? All right, so that is the basics of scientific notation. It's a great way to write huge numbers in a very quick way and very, very small numbers in a very quick way.